NASA has just released a new update on 3i ATLAS today, and the word they used in the report says it all. Unsettled. Not stable, not calming, not predictable unsettled. If you've been following this interstellar visitor with me and you don't want to miss what happens if it keeps refusing to calm down, make sure you're subscribed, leave a like, and stay with me until the very end. Because today's update quietly confirms that 3i Atlas is still in the middle of something, not at its conclusion. Here's what NASA saw this time. The first red flag didn't come from a beautiful image, it came from something nobody outside the mission ever reads. The fit quality. Every day, observatories and spacecraft send in new position measurements, tiny dots on the sky that tell you where 31ATLAS actually was at specific times. You feed those into an orbit solver and ask, does yesterday's solution still work? Today, the answer was no, in a very specific way. When they used yesterday's parameters, the same non-gravitational forces, the same spin-linked out, modeled the predicted positions didn't quite match the actual positions. They missed, but not randomly. They missed in a pattern. All the new points sat slightly off to one side of the predicted track, like the comet had quietly leaned away from the path they had just finished refining. That's not noise, that's behavior. To fix it, they had to tweak the non-gravitational acceleration again, the minuscule gas engine effect of jets pushing on the nucleus. The updated fit wants that push tilted in a new direction and stay in stronger than fading comet models would normally allow. In other words, the trajectory is unsettled because the forces driving it are unsettled. While the orbit team was wrestling with that, the imaging team was doing what they always do, stacking and sharpening the most recent, deep exposures to examine whether the coma and tail had changed. And the same story shows up in images, just told in a different language. In last week's stacks, the inner coma appeared stretched but coherent, one main bar of brightness, a clear preferred axis, and a tail that curved in a way you could almost get used to. In today's stacks, that inner structure has twisted again. The brightest part of the coma is no longer aligned with the old bar. It's rotated, like the spine inside the glow has been grabbed and turned a few degrees. One side of the inner coma has thickened. The opposite side has shrunk and grown ragged. Farther out, the tail shows a faint kink, a subtle turn that wasn't there before, as though the dust stream has begun tracking a new direction of thrust. Coming off the nucleus, none of this screams catastrophe. All of it quietly whispers, nothing here is settled. Rotation is the next piece. To understand how 3i Atlas is spinning, NASA's teams track how its brightness rises and falls over hours. A stable rotator gives you a clean, repeating light curve. Same peak height, cycle after cycle, with the same timing. That is not what today's light curve looks like. When they folded the newest photometry over last week's rotation period, the peaks didn't line up. Some cycles peaked a little higher, some a little lower. The timing drifted just enough that no single period could make the whole pattern fit. To get a decent solution, they had to let the rotation period itself drift again and allow small changes in amplitude from one rotation to the next. Translated, the comet's spin isn't just smoothly speeding up or slowing down. It's wobbling. Sometimes more surface area faces the sun, sometimes less. Sometimes the most active regions line up perfectly. Other times they're half in shadow. The result is a brightness pattern that refuses to settle into a single rhythm. Put the three main pieces of today's data together. The orbit solution needs yet another adjustment to the outgassing force. The coma and tail geometry have twisted into new asymmetry. The rotation signature is unsteady, drifting, and irregular. That's the observational meaning of 3i Atlas is unsettled. So what's actually happening inside this thing? One picture that fits the data is this. The heart of 3i Atlas is being pulled in three directions at once. Thermally, it's still adjusting to the heat it absorbed near the sun. The outer layers already lost their most volatile ice. More stubborn pockets are activating along different fracture networks. Dynamically, its spin state is being altered by those jets. Every off-center vent applies a tiny torque over thousands of rotations. Those small torques add up, tilting the spin axis and changing which regions get cooked in the next cycle. All of this is happening inside a body that was never meant to be rigid, porous, ancient, cracked mass from another star system, trying to redistribute stress fast enough to keep itself in one piece. On some days, those three factors line up, just enough to make it look like 3i Atlas is calming down. The brightness dips slightly. The tail looks cleaner. The orbit solution holds for more than one iteration. Then a deeper pocket vents. A new crack reaches the surface. The spin wobbles a few degrees and everything shifts again. That's where we are today. Not in the middle of a dramatic explosion, not in the comfort of a quiet fade, but right in between. Settled. There's another, more subtle clue. buried in the latest spectra, the breakdown of the comet's light by wavelength. Compared to earlier observations, the ratio of gas emission to dust reflection near the nucleus has shifted again. Lines associated with deeper volatiles remain visible. The inner region shows a slightly different color balance than the outer halo, suggesting fresh material from inside the nucleus is still being tapped. Not just recycling the same surface layers. Every time that happens, you're not just adding gas to the coma, you're forcing the interior to rearrange. Pressure pockets, empty, voids, form. The crust above collapses, or sags, and stress lines migrate. If those stresses had found a new equilibrium, the data would reflect it. Stable spin, stable jets, stable non-gravitational forces, the fact that everything in today's update required. Yet another correction is NASA's way of saying that equilibrium hasn't been reached. So where does this go? In the best-case scenario, 3IATLAS is in the final raucous stage of its evolution. The remaining pockets vent, the wobble damps out, the jets weaken, and it leaves our solar system scarred but intact and elongated yet surviving interstellar comet. In the more worrying scenario, this unsettled behavior means internal stress is still building, and each new vent and spin tweak pushes the structure closer to its limits. Our own solar system's comets have taken both paths. Some stabilized after others stayed unsettled until one update wasn't just an adjustment. The nucleus was gone. Right now, 31A TLAS is still officially one object. No confirmed fragments, no clear debris stream, just a lot of motion under the hood. But today's log is the kind of quiet turning point that matters. The numbers aren't calming. The shapes aren't calming. The spin isn't calming. They're all still evolving, and not in a simple direction. Think about the implications for a moment. We're watching an object from beyond our solar system, something that wandered interstellar space for untold time, now undergoing changes we've never witnessed before. This isn't like tracking a familial comet we've known for decades. This is genuinely new territory. The way 3I Atlas is behaving tells us something profound about the nature of interstellar objects. They don't play by the same rules as our homegrown comets. There might be a different composition. The structure could be radically unlike anything we've studied up close. And the way it responds to our sun's heat is revealing details about the conditions in whatever distant stellar system it came from. Every measurement, every slight deviation, every unexpected twist in the tail is a data point we've never had access to in the past. Scientists are literally writing the textbook on interstellar comets as this unfolds. The models they're building right now will inform our comprehension of these visitors for future generations. But here's what makes this particularly fascinating. The unsettled nature of 3I Atlas isn't just a quirk or an inconvenience for the researchers trying to track it. It's information. Each wobble, each shift in outgassing, each adjustment needed to trajectory calculations is telling us about the internal structure and composition of this object in ways we couldn't learn if it was behaving predictably. When you see that the rotation period keeps changing, that's not just messy data. That's the comet telling you about its mass distribution, about where the heavy parts are versus the light areas, which demonstrates how irregular its shape must be. A perfectly symmetrical sphere wouldn't wobble like this, but 3I Atlas clearly isn't anything close to symmetrical when the jets keep firing in unexpected patterns. That's revealing the geology of, you can call it of, a spaceship between stars. It means there are pockets of volatile material at different depths. It means the internal structure has layers or veins of different compositions. It means this thing has a history written into its physical makeup, and that history is from somewhere completely different than here. The spectral data is particularly intriguing. Those deeper volatiles, they're detecting the ones that are still showing up. Even though the comet has moved away from its closest approach to the sun, those are materials that were buried, protected, preserved from whatever this comet has been through it in its long journey between the stars. Think about what had to happen for those materials to still be there. This thing avoided being completely stripped by whatever star it originally formed around. It survived ejection from its home system, possibly in some violent event. It traveled through the radiation-filled environment of interstellar space without being completely sterilized, and now it's releasing these preserved samples right where we can study them. Every gas molecule escaping from 3I Atlas right now contains atoms that were last part of a forming planetary system around a different star. The carbon, the nitrogen, the oxygen, whatever complex molecules might be hiding in that mix. They all tell a story about chemistry that took place a very long time ago. And the structural response we're seeing, this refusal to settle down, is probably advising us that 3I Atlas is far more fragile than it looks. Comets from our solar system can be pretty tough. They've been through many passes around the sun, They've developed protective crusts. They've lost their most volatile components long ago. But 3I Atlas is a newcomer to the solar system. Whatever protective mechanisms it had from its original environment might not be well suited to our sun's particular taste of heat and radiation. It's like watching someone from a cold climate suddenly dropped into a desert. The adaptation is happening in real time, and it's messy. The fact that NASA keeps having to revise their models isn't a failure of their science. It's actually a success of their observation methods. They're catching changes fast enough to see them as they happen. If they were only checking in once a month, they might miss these transitions entirely. But with daily updates, with continuous monitoring, they're getting to see the evolution play out step by step. This is why the word unsettled is so perfectly chosen. It is not disastrous. It isn't stable. It's in flux. It's transitioning. Additionally, transitions are frequently where the most interesting science happens, where you learn the most about how systems work under stress. Now, imagine you're one of the scientists watching this data come in every day. You spent your career studying comets, maybe even interstellar objects in theory. And now you've got live data from a real interstellar visitor going through its closest solar approach. Every morning, you check the latest observations, and every morning, something has shifted again. That would be simultaneously thrilling and frightening. Thrilling because you're seeing things no one else has ever seen. Nerve-wracking because you genuinely don't know if tomorrow's update will demonstrate ongoing changes or something more dramatic. The comparison to comets that have broken apart is not alarmist. It's just realistic. We've known for decades from comet observation that there's a line between stressed but holding together and stressed past the breaking point. We've seen comets cross that line, sometimes slowly, piece by piece, sometimes suddenly, just gone one day. 3I Atlas hasn't crossed that line, but the continued unsettled behavior means it's operating in a regime where that line exists and is potentially reachable. The question is whether the internal forces causing all this activity will exhaust themselves first, or whether they'll build to a point where the integrity of the structure fails. And here's the problem with making predictions. We don't have enough yet. Not enough examples of interstellar comets under solar stress. Not enough understanding of what this particular object is made of deep down. Not enough knowledge of its thermal history or structural weak points. So we observe, measure, model, and wait to see what happens next. The beauty of modern astronomy is that it allows us to observe this unfold in near real time. Previous generations of astronomers might have gotten a few observations spread over months or weeks. Now we get daily updates. We can see the process. Not only images of the state before and after, every bit of information that goes into those NASA reports is helping build a more complete picture. The positional measurements constrain the forces. The brightness variations constrain the rotation and surface properties. The composition is constrained by spectral data. And when you combine all those constraints together, you start to narrow down what's actually possible right now. What's possible is still a pretty wide range, from gradual stabilization to potential fragmentation, with a lot of intermediate scenarios in between. But each day of new data narrows that range a little more. Each revision to the models rules out some possibilities and strengthens others. This is science in action, not the clean, finished product you see in textbooks, but the messy, uncertain, exciting process of trying to understand something genuinely new. So, if you want to see whether the next NASA entry finally says 3I Atlas is stabilizing, or whether it says the unsettled phase just escalated again, make sure you're subscribed. Stay tuned, and as always, stay curious. I'll see you in the next one.